Good morning. I'm talking with Eyal Weiss, founder and CTO of Cybord, an Israel-based company who is going to announce a totally new product on the show here. You are at the booth of Fuji. Your company is totally software focused. So why are you here at the Fuji booth with all these machines around?
Well, that's a very good question, because we're a software company, and it's not just this. We are a software company focusing on electronic components, on the material. All this show, this booth, Fuji, and everyone else is focused on process. They're trying to do the best quality process there is, and they're succeeding. The quality of placement and testing is very, very good. But components, you just buy. You don't do anything with them. You don't check them, you don't test them, you just buy them from a trusted source. There's no technology for components. So what it means that for electronic products, because the process is so good, most of the issues are actually coming from components. So what we're trying to do is basically look at the components and use technology to do that, and not just on the process, but on the components. And because nobody's doing anything about it, even if you do a small thing about improving the quality of your components, the impact on the efficiency, the quality and reliability would be huge. So this is why we're here, basically.
Okay, so your system is able to detect fake products as well?
Yes. What we're doing, because we're a software company, we're using images of components or pictures of components to analyze them. And based on image of component, we can tell if the component is what it is supposed to be, or is it from the right manufacturer, or is it a counterfeit. We can detect if it was stored properly, because we can see evidence of corrosion or mold or cracks or bent leads or missing balls, just by looking at the components. Of course, only from the outside, we're not seeing the inside. And we're just using images of components to do that. Now, we can get images from basically any kind of machine. We are in Fuji booth, so we're getting images from Fuji machines, from their pick and place machine, because right after the component is being picked up, a camera takes this picture from the bottom side to do accurate alignment. So there is already a camera taking a picture of the component anyway.
And you have a big library with data sheets from all these components?
Yes, but not data sheets. We have a very, very big database of 4 billion components that we have seen from many, many machines and many customers. And we're not using a database data to compare it with. We're using AI and big data tools for that. What we basically do is, because we have so many components in our database, we find the AI algorithm is finding the essence of what makes this component different than the other one. For example, what's the difference between a capacitor made by Murata to the one made by Samsung? Although they are both almost exactly the same, after you've seen 100 million components from Murata and from Samsung, you can tell the very, very small difference between them. And seeing this small difference allows them to detect that this is a Murata and this is a Samsung, so we can detect if it's a counterfeit or not. But we can also say how different it is from a normal capacitor made by Murata, so we can find defects. Because if it deviates from how a Murata capacitor should look like, then there's an issue there. And we can also classify what kind of issues and so on.
Okay, so it's like a bullet which was shot from a gun, and you can identify the gun where the bullet was shot.
Exactly. This is a very good example. It's like forensics. All the bullets are the same and all the barrels are the same, but still every barrel leaves a special fingerprint on every bullet, so you can identify where it came from. So this is actually one of the tricks of how to make it happen. We're basically not really identifying the component per se. We're actually identifying the machine that packaged it, that imprinted that specific fingerprint on it.
During which process steps the measurement takes place?
Well, it depends where we get the images from. Basically, we're a software company, so we have an API that can work either in the cloud or on the edge. And we need to get the images from machine. So the machine could be a pick-and-place machine like we have here in Fuji, or it could be a UI machine. Any kind of machine that can give us pictures we can process. And everything has to be completely automated because this is a production line. And you can't just let people see pictures of component and make decision, this is good or this is bad, I need to reject or not. It has to be completely integrated. So the stream of images goes to the system, and then the system tells through an API automatically to the MES system or the production machine, there's a bad component here that needs to be replaced. So automatically the board with the bad component is moving to the NG tray, so it can be replaced with the good components. So it's completely in line with the process. Now, there's different point of value for different types of customers based on that, because what we're seeing basically is we're seeing the components, but different customers need different things. So an EMS needs to produce efficiently using a good material, and you don't want to have any slowdowns and any interference and any intervention and more manpower to handle it. So everything has to be completely automated. And the features that they're looking for is features that regard to the quality of the assembly in that time. For example, if we find a bad component, we can reject it, and that's perfect for them. They don't want to hassle with that. And another thing is that if you find that the wrong component is being placed, so it was supposed to be this part number, but they actually accidentally placed another one, then we can block this immediately, so to prevent more bad boards to being produced. And if there's a reel that is completely contaminated with corrosion or mold, then we want to block it immediately so the damage will not happen in the future. So all the things that are important for the EMS is the now. Fix it now, prevent it now. And this we can deliver. This is the tools that we are supplying to the EMS. To the OEM, on the other hand, all this capability of seeing the information is important to the life cycle of the product, because they want to have the life cycle quality. And if we saw issues with a component during production, and later on the product did go out to the field, and then they can do failure analysis and can find out what was the common ground for the issue if it came from the components themselves. So imagine that you have a system that is deployed, I don't know, somewhere on an antenna in Norway. We have in our system, or the customer will have in our system, the pictures of all the components in this board, top side and bottom side, the quality score, their issues at time zero. So now they can do failure analysis very, very efficiently and very, very well. We can also have individual component level traceability. That's something also worth mentioning. Because we're seeing the marking on every component, we identify what it means. So we're seeing the component and we understand that this is the date code, lot code, and part number of this component. So this is traceability information, basically. But it's not based on traceability information that we get on paper, but it's what we actually see on every individual component.
So, seems to be quite a complex product.
It's a lot of capabilities, because once you see, you cannot unsee it. Now that you see the components, you can use it to many applications, because again, nobody's today handling the components, only the process.
Mm-hmm. Okay, so you founded the company in 2019. Where comes the idea from? Why did you think it's appropriate to develop such a system?
Okay. I was working on a very, very large program. What I do is develop technology. That's my thing. I was working on a project which I invented from invention to prototyping to full production completely new technology. So it's something completely new. 15 years with a team of 25 engineers and scientists. And after we started deploying the system in the field, after a few months, we started having failures. And they all went through very rigorous qualification and testing. And after a few months, we started having failures. It took us 4 months to find out that the failures actually came from production, not from the new technology, but from a capacitor. One of the reels of capacitors was, let's say, not in good condition. And it was like almost destroying the project was almost canceled. It was a €1 billion project. It was almost canceled because of a 1 cent capacitor. And when we went to manufacturers and asked them, how come you don't check the components? They told us there's no such thing as testing the components. You just buy them from a trusted source and that's it. So after eventually the project was successful with a delay of about a year, I knew what my next project is going to be.
and you succeeded in convincing the investors to give money for the startup company.
Yeah, it's hard work.
It's hard work, yeah.
Hard work because it's completely new. I mean, nobody's doing what we're doing.
Yes.
So we have to convince people that it can build the value.
I can imagine it's very hard to explain to investors. Huh?
It's very intuitive to understand why it's important. Because it's obvious that all the issues are actually coming from the components and you see it, and every engineer you talk to them will say, yes, I had this before. So it's very understandable. But what's difficult to convince sometimes is because everybody are doing things in a certain way and they're used to it. And now you're coming to disrupt the way they're working, and this is a very conservative industry. So it's really, really hard. But everybody we talk to, especially partners we have here, see the value. And we believe that together we can really make a huge difference. Think about it. Most of the issues you have, why is your laptop surviving only 2 or 3 years? It's components. It's the quality of the components.
And maybe the manufacturers are happy with that.
I think that everybody will be happy to get a very good quality, because very good quality material means that you don't scrap this laptop after 2 years, so there's no waste and no emission and no damage to the environment.
You feel big interest from prospective customers here on the fair?
Yeah, we had a great show. We really, with the help of our partners, we really got a lot of very, very good responses here. And we hope this continues today also.
Okay, thank you very much.
Thank you so much.